Hello students, this is Varun. Till now we have studied about rationals and irrationals. We know that real numbers consist of rationals and irrationals. Now we will discuss some facts about real numbers. And the first fact is sum of two rationals is always rational. Means rational number plus rational number is always a rational number. Second is rational minus rational is rational. Means difference of two rational numbers is always a rational number. Third one, rational multiplied by rational is rational. Means product of two rational numbers is always rational number. And the fourth one is rational divided by rational. This number may not exist. Now we will discuss the fourth possibility, that why rational divided by rational may not exist. Because we know that 4 upon 3 is a rational number. 0 is also a rational number. 4 upon 3 is a rational number. 0 upon 0 is also a rational number. And if we divide 4 upon 3 by 0, it means what we get? It is not defined. Because we know that any number divided by 0 is not defined. That's why rational divided by rational may not exist. And the next is irrational plus irrational. It may be rational or it may be irrational. Means sum of two irrational numbers may be rational number or it may be irrational as well. Now let us take one example regarding this. We know that square root of 2 and square root of 3 both are irrational numbers, and their sum square root of 2 and square root of 3, this is also irrational. That's why we can say that sum of two irrational numbers may be irrational, but sum of two irrational numbers may be rational as well. So let us take one example in this regarding. We know that minus square root of 2 is irrational and square root of 2 is also irrational. Both are irrational, both are different numbers. And if we add both of these, minus square root of 2 plus square root of 2, we get 0, which is a rational number. Here we have added two irrational numbers. This is irrational and this is also irrational. We have added two irrational numbers, and on adding two irrational numbers, we have received one rational number. Again, minus square root of 2 is irrational, square root of 2 is also irrational. And if we add both of these, we get 0, which is a rational. That is why we can say that sum of two irrational numbers may be rational, as we have proved this, or it may be irrational as well, as we have proved this. In the same way, difference of two irrational numbers may be rational as well as irrational. Means if we subtract two irrational numbers, then result may be rational or result may be irrational as well. Again, I want to take some examples in this regarding. We know that square root of 2 is irrational and square root of 3 is also irrational, and the difference, that is square root of 2 minus square root of 3, which is irrational. That is why we can say that difference of two irrational numbers is irrational, but it may be rational as well. Why? Square root of 2 is irrational. If we subtract square root of 2 from square root of 2, we can see that both of these are irrational, and if we subtract these two, what we get? Square root of 2 minus square root of 2 equals to 0, which is rational. Means difference of two irrational numbers may be rational as well, but the condition is both of these irrational numbers should be same. That is why we can make the statement that difference of two irrational numbers may be rational as well as irrational. Next is product of two irrational numbers may be rational as well as irrational. Means if we multiply two irrational numbers, then their product may be rational or their product may be irrational as well. Again, I want to take some example in this regarding. We know that square root of 2 is irrational and square root of 3 is irrational, And if we multiply square root of 2 by square root of 3, we get square root of 6, which is irrational. That's why we can say that if we multiply two irrational numbers, then their product may be irrational. But on multiplying two irrational numbers, we may get rational number as well. Even in this regarding, I want to take one example. We know that square root of 2 is irrational and square root of 8 is also irrational. And if we multiply these two, we get square root of 2 into square root of 8. That is square root of 16. And we know that 16 is a perfect square. So square root of 16 is 4, which is rational. So here we have seen that when we have multiplied two irrational numbers, we have received one rational number. That's why we can even make the statement that product of two irrational numbers may be rational as well. In the same way, we can make one more statement that if we divide two irrational numbers, we may get rational or we may get irrational number as well. Means quotient of two irrational numbers may be rational as well as irrational. For example, square root of 6 is irrational and square root of 2 is also irrational. And when we divide these two, square root of 6 divided by square root of 2, we get square root of 3, which is irrational. Means on dividing two irrational numbers, we may get irrational number. But on dividing two irrational numbers, we may get rational number as well. So I want to take one example for this as well. We know that square root of 27 is irrational and square root of 3 is also irrational. And if we divide these two, that is square root of 27 divided by square root of 3, we get square root of 9, and square root of 9 is 3, which is rational. Here what we have seen, we have divided two irrational numbers. Square root of 27 is irrational and square root of 3 is also irrational. And on dividing two irrational numbers, we have received one rational number. That's why we can make the statement that quotient of two irrational numbers may be rational as well as irrational. Next is sum of a rational and irrational is always irrational. If we add one rational number to an irrational number, their sum will always be irrational. In the same way, the difference of a rational and irrational is always irrational. But product of a rational and irrational may be rational or it may be irrational as well. Now I want to take some examples regarding this. We know that 7 is a rational number and root 2 is irrational. 7 is a rational number, root 2 is irrational number. If we multiply these two, we get 7 root 2, which is irrational. That's why we can make the statement that product of a rational or irrational is irrational. But I told you that product of a rational and irrational may be rational as well. If we take one number as 0, we know that 0 is a rational number. 0 is a rational number, and let us take example of some irrational number like square root of 3. 0 is rational, square root of 3 is irrational. And if we multiply these two, their product becomes 0, because 0 multiplied by any real number is 0 only, which is a rational. Here when we have multiplied a rational with an irrational, the product has become a rational. That's why we have made the statement that product of a rational and irrational may be rational, as we have proved this, or irrational as well, as we have proved this. Now next is, what about the quotient of a rational and irrational? So for this we have two possibilities. First possibility, if we divide a rational by irrational, then the quotient may be rational or it may be irrational as well. So let us take one example. We know that 3 is a rational number and square root of 3 is irrational. If we divide rational by irrational, their quotient will become square root of 3, which is irrational. That's why we have made the statement that rational divided by irrational is irrational. But the quotient of a rational and irrational may be rational as well. For example, if 0 is a rational, we take 0 as a rational number. We know that 0 is rational. And take any irrational number, let it be square root of 7. So 0 divided by something, we know that 0 divided by any non-zero real number will be 0 only. So here what we have seen, rational divided by irrational, and the result is rational. That's why we have made the statement that the quotient of a rational and irrational means if we divide a rational by irrational, the quotient may be rational as well as irrational. And there is one more possibility regarding the division of a rational and irrational. So let us look at that possibility as well. In previous part, we divided rational by irrational. But here we are going to divide irrational by rational. If we divide one irrational number by a rational number, then their quotients may be irrational or it may not be defined. So I want to take some examples. Let irrational number is root 3 and rational number is 7. And if we divide these two, root 3 divided by 7, we get root 3 upon 7, which is irrational. Means when we have divided one irrational by a rational, we may get irrational. But if we divide square root of 3 by 0, we know that square root of 3 is irrational, whereas 0 is rational. So we get square root of 3 upon 0, which is not defined. That's why we can make the statement that when we divide irrational by a rational, we may get answer as irrational or answer may be not defined as well. So you need to mind one thing, that whenever we divide irrational by a non-zero rational, when irrational number is divided by a non-zero rational, then quotient is irrational. But when irrational number is divided by 0, then it is not defined. Now students, I want to discuss one more thing with you, that is pi. In previous classes, we have studied that the value of pi is either 22/7 and sometimes we use 3.14. We have read that the value of pi is 22/7 or sometimes we use the value of pi as 3.14. It means pi is a rational because 22/7 is a rational, so pi is a rational. But to your surprise, I want to mention that pi is not rational, pi is irrational. Now the question is, why pi is irrational? If pi is irrational, then how it can have the value of 22/7? So students, for this, let us recall the circumference of a circle. We know that circumference of a circle is 2 pi r, or we can even say circumference is pi into d. Circumference refers to length of the outer boundary of the circle. Circumference of a circle is pi into d. From here we can find the value of pi, and that will become c upon d. Means pi is the ratio of circumference and diameter of the circle. Since pi is the ratio of circumference and diameter, and when we measure a length with a scale or any other device, we only get an approximate rational value. Means we never get exact value. Therefore, we may not be able to realize that either 3 means either circumference or d, that is diameter, is irrational. As we can never approach to a particular value of pi, that's why pi is irrational. Thank you.